Let's move on to the next tab, which is the test tab. Okay, test tab. And there is a very important selection that you parameters that we need to set, and this is the first cut position. So as you know, the i1000 itself has a 36 slot cut cage, and the first slot number 1, is being taken up by the measurement cut. So that leaves the slot number from slot 2 to slot 36 available for pin cuts to be inserted. So being a press down model or even a vacuum model, the user can select where to install, or rather which slot number to start connecting the fixture to. For example, even I have a full module or full cut cage full of pin cuts, right? And my fixture only uses maybe 5 pin cuts itself. I can choose to connect my fixture to starting from any of the cut slots, and not necessary to be slot number 2 to be the first pin cut. It is not necessary to be that. So depending on where the fixture is being connected to, right, this will the user have to set the first cut position correctly. For example, if my fixture today is connected to cut number 2, slot number 2 onwards, meaning slot number 2, number 3, number 4, number 5 onwards, then I'll have my first cut position set at 2. If I am connecting my fixture to maybe slot number 10 onwards, then I will put this to 10. Basically what this does is that it allows the software to calculate and identify where to turn on, which slot number to turn on the relay when it comes to running the production test itself. Okay, so this is the first cut position. I'm going to put this back to 2. Then you have the repeat fail cycle and the retry fail test. So the repeat fail cycle basically allows you to retest the board when there is a failure. Then the retest is only happening on those tests that is failing, and this actually comes with a release of the fixture and re-engagement of the fixture itself. So it's very useful when you are trying to tackle fixture contact issues and to use the repeat fail cycle. Retry fail test basically will basically just retest or rerun the failing test itself, and this doesn't move the fixture at all, right? It just run another time for whichever test that fails. So I'm just going to leave this at 0 for now. Then you have the open shot settling delay. This is a delay time being applied to any of the capacitive loaded nodes during the open shot testing, but just leave this as default and we are fine. Fixture release delay is, in terms of milliseconds, is basically to control how much the press down fixture or press down unit will release. So just leave this at 2 seconds. That's fair enough. Temperature threshold currently is not in use, right? It doesn't matter what threshold that you set here. There's no temperature control right now on the i1000 system. Then you have a discharge threshold, now currently by default being set to 0.1 volts. So meaning to say that anything that is above 0.1 volts will be turned on for discharge. Okay. Then further down you have a couple of check boxes to determine how do you want to operate the test. The first 3 basically is controlling the test sequence. The first one, if you check this, it says auto start after fixture engage. So what happens is that when you place the board onto the fixture and you engage the fixture, the test program will automatically start testing, right? The operator do not need to click on the test button anymore. So if you do not click on this box itself, the test operator has to manually click the test button in order to start the test. So I'm just going to leave this on. Okay. Then you have the abort test when there is an opens or there's a shorts failure. So you do not want the test to carry on. So when there's some opens or shorts failure, just terminate the test itself. The bottom 5 is basically enabling the test groups that we see over here. On the i1000, the whole test sequence is being divided into about 5 categories. We have the discharge, which will be doing the discharge itself. And then you have the opens test, the shorts test. The components test is basically all the analog unpowered test itself. RLC, transistors, diodes, VTAP, climbing diodes, everything it will be lumped inside here. And then you have a function group, which basically is a power up test of the i1000. Right, this is where you turn on your power supplies, and this is where you do your serial programming for your SPI, I2C, stuff like those. So you can selectively turn on whichever group that you want to run. Right, for example, I can just turn on everything and just click OK to save it. Okay. The next tab is the network tab. This is more for data logging. Okay, so data logging itself, it allows you to set your different log path. You can just simply set your failure path to whichever directory that you want. Okay, and then basically the log files will be saved inside that directory itself. There are some parameters that you can actually customize, meaning to say that you can actually type in your own name in these parameters, and it will actually be used in your data log. So just remember that if you want to turn on data log, other than filling in the path, you need to actually connect the data path itself such that the log files will be created. Alright, without the checkbox over here, the data files will not be created for you. Okay, and then lastly is a panel test tab. This tab basically allows you to set up a panel test for the i1000 starting from one board. We will discuss this in a separate video, in a totally separate video, because this will actually involve some other selections itself. So I'm just going to leave this as it is right here. Right, so we have the system, test, and network path being discussed. Click OK, save. And there you go. The test software is now being set up correctly. There is one more thing that we need to do, is to select the test groups to be executed. All right. We've gone through the selection for the test category itself just now. Right. Now what we need to do is to select the test groups within the component test to be executed. So go to test groups, click on test groups, and you can see that there are several different groups that you can choose from. So what you will do is to include whichever test that you are doing, that you want to do for your program itself. And this also basically determine the test sequence. In this case, resistor will be tested first, followed by inductor, followed by capacitor, so on and so forth. Right, this actually allows you to customize your test sequence itself. Click on OK, and basically that's it. You are ready to run production boards with the i1000 itself. We will have another separate video to talk about how to perform some debug using the debug editor, the test editor of the i1000, and of course to talk about the panel test itself. So until then, thank you very much for watching, and have a good day. Bye bye.